The story of human evolution in Eurasia is not a straight line but a web of migrations, adaptations, and interactions across deep time. At the heart of this story stand two remarkable sets of fossils: the Neanderthals, who came to dominate Western Eurasia during the Middle Pleistocene, and the Dmanisi hominins of Georgia, who represent one of the earliest known expansions of hominins into Eurasia nearly 2 million years ago. At first glance, the temporal gap between these populations seems enormous. Neanderthals belong to the last few 100,000 years, whereas the Dmanisi hominins date back almost 2 million years. Yet when examined together, these populations illustrate a continuity of dispersals, survival strategies, and ecological challenges that shape the evolutionary trajectory of the human lineage across the shifting landscapes of Eurasia. Imagine standing on the windswept plateau above the river valleys of Georgia nearly 2 million years ago. Across the horizon, the ground shakes beneath the hooves of vast herds: bison, red deer, wild horses, and the heavy shapes of rhinoceros moving in deliberate arcs. Predators circle in the distance: saber-toothed cats, hyenas, and packs of wolves. But among them lurks a stranger kind of hunter, the small-bodied hominins of Dmanisi, armed with rough Oldowan stone flakes. Their survival depends on anticipating the rhythm of these herds, exploiting carcasses when opportunity arises, and learning to adapt to the temperamental Ice Age landscape. Fast forward more than 1 million years, and the scene is eerily familiar. The predators are still present, the rivers still flow through the Caucasus gorges, and the same species of bison, deer, and wild horses continue to dominate the land. Only now the hunters are different: Neanderthals with thrusting spears, fire-hardened tips, and Mousterian flake tools. They too crouch behind ridgelines, waiting for the same herds to pass. Though separated by more than 1,500 millennia, the Dmanisi hominins and the Neanderthals shared the same prey, the same landscape, and the same constant struggle to dominate the ecosystem of the Caucasus. This continuity of animals is not a trivial detail. It is a thread that connects species, cultures, and migrations. The herds of Ice Age herbivores served as living highways, drawing successive waves of humans across the Caucasus. The Dmanisi hominins, primitive yet daring, may have been the first to unlock this corridor. The Neanderthals, arriving later, refined the art of ambushing and butchering the same prey. And when Neanderthals expanded eastward, eventually reaching the Altai Mountains and settling in Denisova Cave, they followed the very same herds that had defined their existence for hundreds of thousands of years. The Dmanisi site in Georgia, dated to around 1.8 million years ago, preserves some of the earliest evidence of hominins in Eurasia. The bones of at least 5 individuals have been uncovered, showing a mosaic of features: small brains, primitive jaws, but surprisingly modern body proportions. Yet it is not only the fossils of humans that tell the story. The surrounding faunal remains complete the picture. Excavations at Dmanisi have revealed an astonishing bestiary of Ice Age megafauna. Herds of steppe bison roamed the valleys, their bones broken and marked by stone tools. Red deer and horses were present in abundance, often butchered at the site. The remains of aurochs, massive wild cattle, and rhinoceroses round out the faunal record. These were not isolated kills. They represent a hunting and scavenging strategy rooted in the predictability of herd movements across the Caucasus plains. For the Dmanisi hominins, survival meant shadowing these animals. Lacking the refined weapons of later humans, they relied on crude flakes, hammerstones, and cooperative strategies. They may have driven wounded prey into ravines, scavenged carcasses from big cats, or startled herds into panicked runs that left behind trampled or injured animals. Whatever the methods, their survival strategy tied them irrevocably to the herds that dominated the landscape. More than 1 million years later, Neanderthals emerged as the next great predators of the Caucasus. Caves such as Mesmaiskaya preserve their bones, tools, and the remnants of their meals. Astonishingly, the faunal record mirrors that of Dmanisi. Once again we see bison, horses, red deer, and aurochs as the central prey species. But Neanderthals were not scavengers. They were skilled hunters, capable of coordinated ambushes and thrusting spear attacks. Their tools, shaped in the Mousterian tradition, reveal specialized flakes, scrapers, and points designed for hide processing and butchery. In some sites, cut marks on animal bones suggest systematic dismemberment and marrow extraction, indicating not only hunting but an intimate knowledge of animal anatomy. This isn't surprising because genetically they are nearly the same as modern humans and should be rightly considered our cousins rather than a separate species. The continuity here is striking. Across 1.5 million years, the prey base remained stable. The valleys of the Caucasus provided the same reliable resources, year after year, glacial after glacial. Neanderthals may have occupied some of the very same caves that Dmanisi hominins once camped near. To a Neanderthal, the land was not new but anciently familiar, shaped by the same migratory rhythms that had sustained earlier hominins. If the herds of bison, horse and deer created a corridor through the Caucasus, they also stretched much further eastward. Steppe environments connected Georgia not only to the Black Sea, but all the way to the Eurasian plains, Siberia, and eventually the Altai Mountains. This is the path the Neanderthals followed. During the Middle and Late Pleistocene, Neanderthals occupied the caves and mountains of the region, leaving behind both skeletal remains and rich assemblages of Middle Paleolithic stone tools. Mesmaiskaya Cave in the northwestern Caucasus preserves some of the most important Neanderthal fossils, including infants whose DNA has revealed genetic connections with Neanderthals as far east as the Altai. Migration simulations described in a new study shed light on Neanderthal dispersals across northern Eurasia, showing how these hominins could have traversed vast distances from the Caucasus Mountains to the Altai in as little as 2,000 years under favorable conditions. The study explicitly emphasizes that the Caucasus Mountains functioned as a starting point for Neanderthal dispersals towards Siberia. These findings highlight the extraordinary connectivity of Eurasia via river corridors, steppe environments, and glacial refugia, and they provide an opportunity to situate the Neanderthal story within the deeper history inaugurated by the Dmanisi hominins, who first blazed a path into the Caucasus over 1.7 million years earlier. The Caucasus, therefore, becomes a pivotal landscape for understanding both the earliest hominin dispersals and the later Neanderthal expansions. The simulations show that Neanderthal groups could leave the Caucasus, follow the river corridors of the Volga and Kama, cross the Urals, and eventually reach the Altai in as little as 1,600 to 2,000 years, depending on the climatic window. Such rapid dispersal would have been facilitated by landscapes of open steppe during interglacial periods, when rivers provided both water and natural highways. Conversely, glacial advances often cut off connections, isolating populations and forcing them into refugia until conditions improved. This oscillation of connection and separation mirrors the deep time dynamics that also shaped the Dmanisi dispersal. The simulations suggest that once Neanderthal groups began moving east from the Caucasus, their foraging strategies and river-following behaviors naturally funneled them toward Siberia. This is an echo of the same exploratory impulse that carried Dmanisi hominins into Eurasia in the first place. According to the study, Neanderthals dispersing from the Caucasus Mountains to the Altai region near Denisova Cave required close to 1 million individual steps in the simulation to complete the journey. If we assume an average Neanderthal generation length of about 25 years, this would equal approximately 65 to 80 generations. The model therefore suggests that the migration from the Caucasus to Denisova could have been accomplished within a relatively short evolutionary timescale, unfolding over only a few dozen generations of Neanderthal families. For Neanderthals, the time period between 120,000 and 60,000 years ago presented harsh challenges. Oscillating glacial and interglacial periods transformed Eurasia into alternating deserts, steppes and tundras. The study emphasizes how glacial barriers isolated western and eastern populations, only for interglacial conditions to reopen corridors. This stop-and-go pattern parallels the ecological bottlenecks and expansions that must also have structured the Dmanisi dispersal. In both cases, hominins moved when landscapes permitted, retreated when conditions deteriorated, and adapted to a patchwork of habitats. Both Dmanisi and the Neanderthal dispersals highlight the Caucasus as one of the most important crossroads in human evolutionary history. Geographically, the region forms a natural corridor between Africa, Europe, and Asia. For the Dmanisi hominins, it was the first stepping stone into Eurasia. For the Neanderthals, it was a major refuge and launching point for expansions into Siberia. The simulations underscore this role by demonstrating that starting points in the Caucasus, whether north or south of the mountains, were critical for determining the likelihood of successful dispersals. Routes out of the Caucasus connected to major river valleys such as the Volga, Kama, and Irtysh, which served as highways into the heart of Eurasia. The very same geographic connectivity that facilitated the earliest migrations also shaped later Neanderthal expansions. One of the key findings of the study is that Neanderthal dispersals from the Caucasus to the Altai could have been rapid, occurring in less than 2 millennia. Such speed implies that archaeological traces along the route would be sparse, since groups moving quickly would not have left many durable settlements. This helps explain why there are so few known sites linking Europe and Siberia, despite genetic evidence of contact. This insight can also be applied retrospectively to Dmanisi. The scarcity of sites from the earliest into Eurasia dispersals may similarly reflect the rapidity of movement and the ephemeral nature of campsites. The fact that Dmanisi is preserved at all may be an accident of geology and excavation, offering us a rare glimpse into a population that otherwise left few traces. Thus, the dynamics of dispersal, rapid movement, sparse evidence, and occasional refugia unite the earliest pioneers with the later Neanderthals. When Dmanisi and the Neanderthal dispersals are considered together, a unified model of Eurasian hominin dispersals emerges. In this model, Eurasia is seen not as a distant frontier, but as a dynamic landscape repeatedly colonized by waves of hominins whenever ecological windows opened. Each wave, whether Dmanisi hominins, Homo erectus, Neanderthals, Denisovans, or Homo sapiens, entered through corridors like the Caucasus, used rivers as guides, and adapted to the mosaic of habitats. Each wave also encountered earlier inhabitants, sometimes replacing them, sometimes interbreeding, and sometimes coexisting in fragile balance. The Dmanisi fossils capture the beginning of this process, the first tentative steps into Eurasia. The Neanderthal dispersals modelled in the study capture a later chapter, when one branch of humanity expanded eastward to meet its cousins. Together they illustrate the remarkable persistence of dispersal as a central theme of human evolution. Genetic studies confirm that Neanderthals ranged far beyond Europe, expanding into Western Asia and ultimately into southern Siberia. At Denisova Cave in the Altai, Neanderthal DNA has been found in layers dating to around 120,000 years ago and again around 60,000 years ago. The route they took was not arbitrary. It shadowed the same steppe corridors, rivers and valleys that Ice Age herds travelled. This migration eastward should be seen not merely as an expansion of territory, but as an extension of the ecological dance that tied Neanderthals to their prey. To pursue bison, horses and red deer was to pursue survival itself. The Neanderthal colonization of Denisova Cave is thus the logical conclusion of a process set in motion over 1.7 million years earlier at Dmanisi, when hominins first learned that these herds could be followed indefinitely into the heart of Eurasia. What does this tell us about human evolution? It underscores the idea that animals were not just prey but guides, leading hominins across continents. The Dmanisi hominins discovered a hunting ground that sustained life on the edge of Europe and Asia. Neanderthals inherited the same ground, mastered the same prey, and pushed the strategy eastward. The story is not simply about tools, skulls, or genetic markers. It is about ecological continuity. The fact that the Ice Age world created stable pathways of migration that remained viable for over 1.7 million years. Dmanisi to the Caucasus caves to Denisova in the Altai. This is not just a story of human dispersal, but of hunters following herds across an endless steppe highway. The connection between Dmanisi and Neanderthals is not abstract. It is written in the bones of animals. Across vast spans of time, two very different kinds of humans depended on the same species for survival. The valleys of the Caucasus echoed with the same sounds of trampling hooves, panicked herds, and the clash of hunters closing in. From there, the Neanderthals carried the tradition eastward into the Altai, where Denisova Cave preserves the final echoes of their expansion. In this way, the herds of the Ice Age were more than food. They were the living threads of human history, connecting early Homo erectus at Dmanisi to the Neanderthals of the Caucasus and the Altai. When we speak of migrations and dispersals, we must remember that they were not migrations of humans alone, but of humans and their prey, bound together in the same timeless struggle for survival. One of the most striking aspects of connecting Dmanisi and the Neanderthals is the continuity of dispersal behavior across nearly 2 million years. Both populations demonstrate that Eurasia was not an impassable wilderness, but a corridor of opportunity, where mobile groups could expand quickly when conditions allowed. Although separated by more than 1.7 million years, the Dmanisi hominins and the Neanderthals can be connected through the geography of the Caucasus, the dynamics of dispersal, and the ecological challenges of Eurasia. The Dmanisi hominins were the trailblazers, proving that early Homo erectus could thrive in new environments with limited technology. The Neanderthals were heirs to this legacy, expanding across the same landscapes with more advanced tools and greater resilience. The simulations demonstrate how Neanderthals could rapidly traverse Eurasia, echoing the pioneering movements of their distant predecessors. Seen in this light, the Dmanisi and Neanderthal stories are not separate, but part of a single grand narrative of human expansion. They reveal that migration, adaptability, and survival across vast and shifting landscapes have been central to our lineage from the very beginning. The Dmanisi fossils mark the dawn of Eurasian exploration, while the Neanderthal dispersals mark its later flourishing. Both underscore the same enduring truth, that the story of humanity is the story of movement. Thank you for watching.